All right, buckle up, everybody. We're diving into the world of quantum science today.
Oh, that should be fun.
To be more precise, we're looking at Ohio State University's Center for Quantum Information Science and Engineering.
CQISE.
That's the one, CQISE. We've got their website pulled up and a couple articles about these things called quantum states.
Sounds like something straight out of Star Trek.
Right. It's all pretty mind-bending stuff, but how close is it to actually impacting our lives?
Closer than you might think. We're not talking warp drives or teleportation just yet. But
Right.
quantum information science is about using the, shall we say, unusual rules of the microscopic world to create real-world breakthroughs.
Okay, so less about spaceships, more about what?
Think about things like ultra-secure communication networks. What about computers that can design life-saving drugs? Or sensors that can detect the tiniest of tremors deep within the Earth?
Okay, now you're speaking my language.
Yeah.
I was reading through CQISE's website, and they mentioned something called a second quantum revolution. Before we get into that, can you give us a quick rundown on what the first quantum revolution was? For those of us who might not have been around for it.
Of course. The first quantum revolution, that's what gave us a lot of the technology we take for granted today. Lasers, for instance. Transistors.
Which are in pretty much every electronic device ever.
Exactly. And even MRI machines in hospitals, those all rely on quantum mechanics. But the truth is, we were just scratching the surface back then.
So we have the appetizer, now we're getting to the main course.
Precisely. This second quantum revolution, it's about truly mastering and manipulating those quantum effects, pushing for even bigger and bolder breakthroughs.
I like the sound of that.
Yeah.
And it seems like CQIZ is going about this in a really interesting way. Looking at their website, they're not just focused on research.
It's true.
They're also big on partnerships, getting students involved, and community outreach.
Well, they understand that this isn't just about making a scientific breakthrough in a lab somewhere.
It's bigger than that.
Much bigger. Quantum technology, it's about building an entire ecosystem. You need physicists, obviously, but also engineers, computer scientists, ethicists, even people with business savvy.
Yeah.
You need all hands on deck.
That makes a lot of sense. Everyone brings something different to the table. I did see something interesting on their news section. They're working on building an intercity quantum network between Columbus and Dayton.
Fascinating.
Right. So, first of all, what does that even mean? What is a quantum network?
Imagine a communication network that's virtually unhackable.
Okay, now you've got my attention.
That's the promise of a quantum network. It utilizes something called entanglement, which is like this invisible link between quantum particles. It's mind-boggling.
I bet. You're going to have to break that down for me.
Okay, imagine two coins, right? But no matter how far apart these coins are, if one lands on heads, the other one always lands on tails. They're linked.
That's wild.
It really is. And that principle, that's what a quantum network can leverage. We're talking about things like unbreakable encryption for things like online banking, government communications, even just sending messages to friends and family.
So much faster than waiting for a letter in the mail.
And exponentially more secure. This network that they're building in Ohio, that could be a proving ground for tech that revolutionizes how we communicate and protect information.
It's like something out of a sci-fi novel, but it's happening right here, right now.
Science fiction today is often science fact tomorrow. And speaking of things that might sound like science fiction, you mentioned quantum states earlier.
Oh, yes. That article I was reading, it described them as containers, holding all the information we know about a system.
It's a way of thinking about it.
But then it also said that they change over time and involve probability. How do we even wrap our heads around that?
All right, let's try an analogy. Think about flipping a coin, a simple coin toss. Before that coin lands, it has the potential to be both heads and tails, right? Quantum states, they're kind of similar. They exist in this multiple possibilities state until we actually measure them.
So it's not just that we don't know what the state is until we look at it. It's that it's actually in this fuzzy, uncertain state.
Exactly. And then when we measure it, when we interact with it, that's when it collapses into a single outcome, like heads or tails.
Okay, that is seriously blowing my mind right now. It's like the universe can't make up its mind.
In a way, it's one of the most fascinating and counterintuitive aspects of quantum mechanics.
And this is where my brain starts to hurt a little bit. So we've got these quantum states, which are like a coin toss before you actually flip the coin.
A good way to think about it.
And this is where something called the Schrödinger equation comes in, right? That was another term from the article.
Ah, yes, the Schrödinger equation. Now, don't worry, I'm not going to make you dust off your old calculus textbook.
Thank goodness for that.
But basically, think of the Schrödinger equation as a set of rules, a sort of rule book for how these quantum systems behave.
Okay, so there are rules. Even if the universe likes to play dice, there's some method to the madness.
Precisely. It helps us predict how these quantum states, these probabilities, will change over time.
So even though there's randomness, it's not like we're totally clueless. We have tools to make sense of it all.
Exactly. And those tools, that's what allows researchers at CQISE to actually manipulate and control these systems, to harness them for practical applications.
Can you give me an example? How would a researcher actually use this Schrödinger equation in their work?
Let's say you're a researcher and you're trying to design a new kind of sensor.
Like a smoke detector, but way more advanced.
Exactly. But this sensor, it's so sensitive it can detect individual molecules. The Schrödinger equation, it lets them simulate how a specific molecule at the quantum level would interact with that sensor.
So they're basically running simulations to see what works best.
Yes. It helps them design and optimize these sensors for incredible sensitivity.
That's amazing. It's like an equation that can have real-world, tangible impact.
That's the beauty of quantum mechanics. It might seem abstract, but it has the potential to revolutionize so many aspects of our lives.
Okay, so we've talked about these amazing advancements, but how does it impact, the average person? What does a future powered by quantum technology actually look like?
Imagine a world with truly personalized medicine.
Okay, tell me more.
Treatments tailored to your unique genetic makeup. Imagine designing new materials with properties we could only dream of today. And of course, those unhackable communication networks we talked about. That's all on the table.
It sounds like we're on the edge of a technological revolution.
We are.
But are there downsides?
Yeah.
This is some powerful stuff we're talking about. It can't all be good, right?
You're absolutely right. And that's why I'm so glad that CQISE is emphasizing the ethical side of things as well.
So it's not just can we do it, but should we do it?
Exactly. We need to make sure these advancements are used to benefit everyone, not just a select few. Like any powerful tool, it could be misused. We need to be having these conversations now while things are still in the early stages.
I totally agree. We can't just ignore the potential consequences. It's like we're being handed the keys to a brand new universe, and we're still figuring out the rules of the road.
A very apt analogy, but that's what makes it all so exciting.
Absolutely. Okay, but let's go back to this whole quantum internet idea for a second.
Sure.
If it really can't be hacked, does that mean something like online banking? It just becomes inherently safer.
That's the dream, isn't it? And theoretically, yes, it could be. But building a fully functional quantum internet, that's a massive undertaking. We've got significant technical hurdles to overcome, and we need to figure out how it would work with our existing internet infrastructure.
It's not as simple as just flipping a switch.
Not at all. Projects like the one at CQISE are absolutely essential because they're laying the groundwork. They're taking those first steps on a road that leads to a future that's incredibly exciting.
It's like we're paving the way to a world we haven't even fully imagined yet. This entire conversation, it makes me think back to something you mentioned earlier. This idea that quantum objects are inherently probabilistic.
Yes.
What does that even mean? Help me wrap my head around that again.
It's one of the things about quantum mechanics that really throws people off because in our everyday lives, things tend to be predictable.
Drop your phone, it falls to the floor. Basic physics.
Right. We can use physics to predict where that phone is going to land, but in the quantum world, everything comes down to probabilities.
Okay, so back to that coin analogy. You're saying it's not just that we don't know if it's heads or tails until it lands, but that it's actually both at the same time.
Precisely. It's only when we measure a quantum object, when we interact with it in a specific way, that it chooses one outcome or the other. It's like that very act of observation forces it to make a decision.
Hold on, so we're not just passive observers here. Are you saying that our interaction with the quantum world, it actually influences the outcome? That's pretty wild.
It's a common misconception to think that our consciousness directly influences things. It's more about the act of measurement causing the quantum system to transition from a state of potentiality into a definite state.
So our curiosity forces the universe's hand, in a way. That's still pretty mind-blowing.
The quantum world often feels that way. But let's connect this back to the work being done at CQISE.
Please, because I think I'm about to drift off into the quantum realm at this point.
Well, think about it this way. All of this comes into play with quantum computers.
Right. We hear that term thrown around a lot. How are they different from regular computers?
Think about it this way. Classical computers, the ones we use every day, they store information as bits. which can be either a 0 or a 1.
Like a light switch, on or off.
Exactly. But quantum computers, they use something called qubits. And because of this idea of superposition that we were just talking about, a qubit can represent both 0 and 1 at the same time.
Wait, so it's like that coin being both heads and tails at the same time, but instead of a coin, it's information itself.
You got it. It's like having a computer that can explore every possible answer at the same time. That's the power of quantum computing.
So in theory, these quantum computers could be used to, say, break the encryption codes used by banks, governments, all that.
Well, it's not quite as simple as that. They're not magic code-breaking machines. Quantum computers, they excel at simulating complex systems,
Yeah.
like designing entirely new materials at the atomic level, or understanding the incredibly complex behavior of molecules in order to develop life-saving drugs. These are problems that would take classical computers years, decades, maybe even centuries to solve. Quantum computers could potentially do it exponentially faster.
So we're talking about revolutionizing fields like medicine, material science, maybe even artificial intelligence.
Precisely. The possibilities are almost limitless.
It's crazy to think that something as seemingly abstract as the probabilistic nature of the universe, that it could lead to such tangible and world-changing applications. It's amazing what the human brain can come up with.
It really is. And that's why places like CQISE are so essential. They're not just pushing the boundaries of what we know, but they're finding ways to apply that knowledge in a way that could profoundly impact our lives.
It's like we've stumbled onto this entirely new rule book for the universe, and we're still figuring out how to read it.
And the best part is we're just getting started.
I love that. Well, on that note, I think we need to address the elephant in the room here.
Which is?
We've been talking about all these incredible advancements, this ability to essentially manipulate the universe at a fundamental level.
It's powerful stuff, no doubt.
But with great power comes great responsibility, right? So what about the ethical side of all of this?
That's the million-dollar question, isn't it? And it's a conversation we absolutely cannot afford to ignore. As we continue to unlock these secrets of the quantum world, we need to be having these ethical discussions right alongside the scientific ones.
It's not just about what we can do, but what we should do.
Exactly. And those decisions, they shouldn't be made in a vacuum. It can't just be up to the scientists and the engineers. This is a conversation that needs to involve ethicists, policymakers, and honestly, the public at large.
It's a shared responsibility to shape the future of this technology.
I completely agree.
I have to say, this has been eye-opening. We've gone from talking about the weirdness of subatomic particles to the potential for a future reshaped by quantum technology.
It's quite a journey.
It really is. And I think the biggest takeaway for me is that we're just at the beginning of this journey. There's so much more to discover and so many important questions that we still need to answer.
It's a very exciting time to be alive.
Absolutely. And on that note, we'll leave our listeners to ponder the incredible implications of this quantum revolution, from unhackable communication to the very nature of reality itself. We've only just scratched the surface today. But as we've discussed, it's crucial that we proceed thoughtfully and responsibly, ensuring that these advancements ultimately benefit all of humanity. Until next time, keep asking questions, keep exploring, and keep diving deep.
It is, and that's part of what makes it all so important, right? Making sure we're asking those tough questions.
Absolutely. We can't let the excitement of new discoveries overshadow the potential consequences.
Exactly. We need a cautious kind of optimism, I think.
Speaking of optimism, going back to this quantum internet for a second, it all sounds great in theory, but how realistic is it? Are we going to be sending unhackable messages anytime soon?
Well, let's just say it's still early days.
So not ordering my quantum phone just yet.
Not quite, but think about it. Just a few decades ago, the internet as we know it, it was just a distant dream for most people.
True. I remember when dial-up was the norm.
Exactly. And look at us now. We carry around more computing power in our pockets than entire rooms full of computers just a few decades ago. The quantum internet, it's on that same trajectory. It might seem impossible now, but so did so many things that we take for granted today.
Okay, so maybe not tomorrow, but maybe the day after tomorrow.
Exactly. And projects like the one at CQISE, they're paving the way for that future.
I'm starting to see why they're such a big deal. They're not just doing the research, they're actually building the foundation for these world-changing technologies.
And they're doing it in a way that brings everyone along for the ride. That focus on partnerships, on education and outreach, that's going to be crucial in the years to come.
It's like the old saying, if you want to go fast, go alone. If you want to go far, go together.
Couldn't have said it better myself. The quantum future, it's not something that's going to be handed down from on high. It's something that we're all going to build together, one step at a time.
And it all starts with understanding these mind-blowing concepts, one deep dive at a time.
Now you're talking. And speaking of mind-blowing concepts, can we circle back to this whole probabilistic thing one more time? I feel like I'm only just wrapping my head around it.
You and me both. But sure, let's dive back in.
Okay, so imagine this.
I'm trying. My brain is already starting to hurt, but go on.
Imagine a world where, instead of things being one way or the other, they exist in all possible states simultaneously.
Okay, you've officially lost me.
Yeah.
That sounds less like science and more like, well, magic.
It does, doesn't it? But that's the beauty of quantum mechanics. It forces us to rethink everything we thought we knew about how the universe works.
So in this quantum world of yours, how do we get anything done if nothing is certain? How do we even make decisions?
That's where the act of measurement comes in. You see, in the quantum world, when we observe something, when we measure it, we're essentially forcing it to choose one state out of all those possibilities.
So our curiosity, our need to know, it's like we're collapsing the quantum wave function just by looking at it.
In a way, yes. It's a bit like, have you ever noticed how looking for something in a cluttered room seems impossible? But the moment you stop looking, there it is.
All the time.
Well, in a very simplified way, that's kind of what it's like with quantum systems. The very act of observing, of trying to pin something down, it forces it to become definite.
Okay, I think I'm starting to get it. So it's not that things are uncertain in the quantum world, it's that they're everything all at once until we decide to look at them.
Exactly. It's like the universe is holding all the doors open, and it's our choice, our act of observation, that determines which door we walk through.
Wow, that is a pretty profound way to think about it.
It really is. And it gets even wilder when you start thinking about the implications for things like free will and the nature of reality itself. But I think we'll save those for another deep dive.
Good idea. My brain needs a break after all of this.
As do I.
I like that analogy. Makes it a little easier to grasp, even if it still bends my brain a bit. But okay, enough about our brains hurting. We've covered a lot of ground today, from the mind-bending basics of quantum mechanics to the potential of a future powered by these incredible technologies. What are your final thoughts? What should our listeners take away from all of this?
I think the biggest takeaway is that we're on the verge of something truly remarkable. Quantum science, it's not just some abstract theory anymore. It's poised to revolutionize our world in ways we're only just beginning to imagine.
It's exciting and maybe a little bit daunting too, right?
Absolutely. And that's why it's so important for everyone to engage with this technology, to understand its potential and its implications. Because ultimately, the future of quantum science, it's not just up to the scientists and engineers, it's up to all of us.
Well said. And on that note, we'll leave our listeners with that thought. The quantum revolution is upon us. Keep asking questions, keep exploring, and keep diving deep.